Hello, I am Professor Josh Kazin, and this is going to be my course on behavioral economics. This is the introductory lecture on this topic that I think is incredibly fascinating and incredibly important. And without further ado, let's get into it. The introduction goes over what the topic is and through all that nice stuff. So, this is the introduction to behavioral economics. And we're going to start with, well, what is behavioral economics? Very often it's called psychology and economics when this course is taught. What behavioral economics does, is it's going to study the joint influences of psychological and economic factors on behavior on human choice. So, to be good at behavioral economics, to do well in this course, to follow along in these lectures, you really need to have a good understanding of not just the behavioral economics, the psychology that I'm going to teach in this course, but also the stuff that comes before it, the rational economic behavior, the 101 stuff, solving those utility maximization problems. You really need to have an understanding of how do rational people act or how should rational people act in order to understand, okay, why is something I'm going to cover, some cognitive bias, a deviation from that rational behavior, and why is it important to understand and address that deviation? So the main goal of behavioral economics is to use insights from other fields to make economic models more realistic and more predictive. And primarily we pull from psychology, but we also have pulled material from marketing. Context effects comes from there, as well as sociology. And there's been other fields that I'm sure we've pulled from that I'm unaware of. But most often we're going to use the standard model of rationality as a base. And the standard model of rationality is basically the stuff that you learned in your 101 courses, where people act selfishly, you have almost infinitely many people, you have perfect information, all these nice things. We're going to cover those assumptions on the next slide. So to have all that 101 stuff that you learned, the 101 economics, to have the perfectly competitive market work out and all these things, you need these assumptions of rational behavior. You need these to work out. You need perfect preference stability. That says that I prefer one thing or I prefer the same thing from moment to moment. I don't have my mood affect my choice, for instance, would be one deviation from this assumption. So no matter the presentation of goods, no matter my mood, I prefer the same things. Now, you can still, let's say, seasonally prefer ice cream. Like in the summer, I like ice cream much more than I like it in the winter. That's still allowed, but you can't, one summer to the next, suddenly stop preferring ice cream or stop wanting ice cream. You have to have preference stability that's unaffected by, oh, I go to the store and that ice cream looks really, really, really good to me. I want to buy it right now. You just buy the most superior good, the good that has the highest value to you as a consumer in every given instance. That's perfect preference stability. Now, perfect time consistency says that I'm going to look on spans of time the same. I'm going to choose consistently over any span of time. If I'm going to make a decision that affects me now and 10 years from now, I'm going to make a similar choice that decision that affects me now and 1 year from now would have, or now and maybe 1 minute from now. I'm going to treat those spans of time similarly. And we're going to work with those sort of intricacies. That's going to be the first topic that we cover because this ends up being one of the simplest concepts of behavioral economics to present. The next, this one's perfect self-interest. This one you guys should be very well familiar with, coming from 101 courses. This says that I only care about myself. I don't really have any preference over the negative effects that my choices have on others. I don't care about the externalities that I impart on others when I make a decision, when I pollute. And I also don't care about the positive effects when I make a good choice for society. So I only care about myself. And you would have dealt with this assumption a lot working with Coase's theorem, as well as externalities and what's the other topic in externalities? There's the free rider problem is one of the big ones. I think these are all topics you should be familiar with from a 101 course in economics. The next assumption of rational behavior, the next assumption for the standard model of rationality is that you have perfect information. You're aware of all available choices you could make, all available products and their prices, every aspect of those goods. You know their features. You know everything about them when you walk in to make a purchase in the grocery store, for example, or any choice that you do make. Now, a lot of modern economics has done away with this assumption. It doesn't need it. But we're going to work mostly off of the classical material when we're talking about a course in behavioral economics. So we're going to actually work through some of those deviations from perfect information. Or the doing away with it that some models have done. Next is that you're a perfect optimizer. You have perfect optimization. You're able to solve complex utility maximization problems with every single choice you make. You're going to be able to work it out. Okay, this is going to be maybe the fund that returns the most money to me over time, so I'm going to invest in that fund. You're going to put the pen and paper to work and make the best choice in every given instance, and that tends to be quite challenging. Um, so if people could do this, right? If you could do this as an economic student, you'd be getting an A in every course. I'd be giving a lot more A's than I tend to give out in my courses. So we're pretty sure this one's not true, but you definitely need it to motivate the Sarin model of rationality, to motivate the perfectly competitive markets, all these good things that you learn in your 101 courses. And then the last assumption we have here is perfect foresight. I'm aware of the effect of my current actions on the future and future events. This one's incredibly complex at an undergraduate level, so I tend not to go into it in this course, which is designed primarily for undergraduates. But it's one of these assumptions still of rational behavior. So let's talk about now irrational behavior. And my face is only partially obscuring this link here for Google Trends information on calories and diets. So the first example we're going to look at here is limited self-control. And I've already clicked this link here. So I'm just going to pull that up. So if we look at data on Google searches for the word calories in blue and the word diet in red, we're going to notice sort of a trend here. And it's not really well pronounced in the past 2 years, but before that, we have a distinct trend here. In January, right? Okay, searches for diets and calories, they spike way up. But by the time you get to the end of the year, by the time you get to like Thanksgiving and winter, no one really cares so much. So this trend declines over time. Now, why is this a rational behavior? I'm going to let you guys think for a moment on this. I like to ask a lot of questions in my courses. So why is this irrational behavior? What assumptions does it violate here? And it's always hard recording a video lecture because I never know how long to pause. It's hard. You don't get those clues from an audience being there. It's just sort of guess. So I usually like to just talk through it. Anyways, I'm going to just sort of go through my answer for this question now. There's many answers you could come up with here. But this example of limited self-control, it displays a lack of preference stability. It says that my preferences aren't stable over time. In January, I'm saying, oh, I want to diet, I want to lose weight. It's a goal I have because of New Year's resolutions. People make those New Year's resolutions. And that goal doesn't maintain itself over time. So I'm not looking for low-calorie foods throughout the year. My preferences aren't stable throughout the year, at least for the majority of people that choose to go on diets. Unfortunately, that's what the data says. So preference stability is the main one this contradicts. And you could argue to an extent that this violates this perfect price or time consistency, that my choices aren't consistent over time. I think I'm capable of doing the diet in January, but by the time winter comes, I don't care about the future as much. I'm thinking about my next New Year's resolution. And this next example here I have for rational behavior, it's one of these things that is very, very interesting and very, very prevalent, especially at the time of recording these lectures in 2022 in the summer of it, as firms are readily doing this. That is shrinkflation. So this is that phenomena where rather than increase prices at a grocery store because prices are going up, because there's all sorts of economic phenomena occurring, supply decreases, supply shocks is what we call those, that drive up prices. Instead of increasing those prices, firms are going to decrease the quantity per unit sold and keep the price the same. So per quantity, per like units, and I have some examples here, per Frito bag, right, you're getting less. You're getting slightly less. In this case, 5 fewer trips per bag. But the price is the same. So you're paying less or paying the same for less units. Per unit cost is going up, basically. But the sticker price that you see at the grocery store, that doesn't change. That's staying exactly the same. You're just getting a smaller thing. So it should be the same thing as a price increase, but it's not. Oh, clicking the wrong thing there. Hold on here. Find my mouse. All right, it should be the same thing as a price increase, but a price increase should see the quantity demanded drop, should see the quantity demanded decrease. That's not what you see with shrinkflation. You see shrinkflation, the demand stays the same. There's no quantity of demand drop with shrinkflation, even though it's the same thing as raising prices. So how can this happen? It should be that, okay, you respond negatively to a price increase. And that's certainly what's going on. The price per unit is increasing. So we should see the quantity demand drop naturally. But we don't. So it's certainly an example of irrational behavior. But the question is, what assumptions does it violate? And I'm going to just give you guys a moment here to think through those. So think about what assumptions are violated here with shrinkflation. If there's any number you could have here. My answers even aren't necessarily complete, but I'm going to give you guys my answers. The first would be perfect information. You're very often not aware of the volume of units, how much is sold per what you're buying. You just go ahead and go to the store and you see the size of the bag and you assume, okay, that size of the product infers exactly what I'm getting from it. But if you go to the store and you buy like a thing of a box of cereal, okay, the box of cereal can be much, much bigger than the bag inside that box of cereal that actually contains the cereal. So it can be very misleading. So perfect information is certainly violated here for consumers. And then optimizations, of course, violated because they're not really doing the calculation in terms of what's the price per unit. So perfect, where was I here? Perfect information is certainly violated, and perfect optimizations violated. And then oh gosh, not the way I wanted to go. We have perfect preference ability being violated here because my value per unit has changed, but it doesn't. It's not adjusted. I just maintain my habit of buying this bag of Fritos. I consistently stick to that. I don't reevaluate my choice. So I'm stuck on my habit. It takes too much effort in some sense to deviate from purchasing a good. And we're going to talk a little bit about that. It's called the default bias, where people just buy the same products no matter what they actually cost in some cases, or no matter what you're actually getting in other cases, in the case of shrinkflation. All right. Now, those are just examples of irrational behavior, but we still have these examples of rational behavior, and they are useful, right? So they have some use. That's why they've been in practice for so long. We've known for ages, right? We've had psychology as a field of study for, I think, centuries. So we've known that people aren't rational, but we've assumed in economics that they are rational. So the question is, why would we do that? Why would we make these assumptions rationality? And there's one really easy answer to that. It makes things easier for economists to do their work. It makes the math much easier to write an economic model and to make predictions with that model. So we make these assumptions. But they just happen to be unrealistic. So now, as we're getting more advanced in terms of mathematical modeling and data analysis, we're going to do away with these assumptions. We're going to slowly do away with these assumptions, as the trend has been in behavioral economics. So putting all this together, putting all those behaviors of rationality together, we're going to make a model, and I've got to shrink my face here in order to show you this little sticker here. Okay. And we're going to put together this model. This is the standard model of rationality. Put together in a very simple equation any choice you would make, all of your choices. And that's what this model is going to be. It's our baseline model. We're going to work with this model and deviate from it as we add in some irrational behavior, some deviations from rational behavior. Sorry, I've got my dog behind me. It's a lightning storm, so she's going a little bit off the walls right now. Anyways, this model here, it's going to say that rational agents, people that are rational, they're going to maximize their expected utility, which this is an expression of. This is expected utility over time. And they're going to maximize that expected utility in every single period, every single choice they're available to make. X's are the choices here. With some discount factor over time. As you wait longer for rewards, the value of those rewards decrease because of inflation, because of the time cost of money. There's all sorts of reasons for this. You would have covered that in a one-on-one course, that you do have a discount rate, a discount factor due primarily to inflation. So as a rational agent, they're going to maximize their choice, maximize their utility with some choices, and that's going to be subject to, well, what choices are available. That's here. This is our set of choices, is the big X here with the I. And my XIT here, this is the choices I have in any given time period. The utility of their choices here, the utility, oh, I've mislabeled that. I didn't realize I mislabeled that. The utility of choices here, given some state of the world S, which we're going to talk about next. So the utility of each choice I could make. the state of the world in which I'm making that choice. Is it summer? Is it winter, for instance? Is there a recession on? These are things that could be states of the world. The prices of a choice, usually the prices are in here in the X itself, but sometimes it can be in the S. The probability of each state occurring, you don't really know necessarily what happens in the future. So you have to model, you have to think about the probability of the state of the world with each choice that you make. If I'm going to invest in some money, is it probable that that money is going to increase in value? Yes or no? Okay, you have to think about that when you're making a decision to invest in the stock market. And finally, we have time preferences. That's going to be our delta here. And usually we assume that the deltas stay constant over time, although you don't necessarily need that assumption. Typically, you assume the discount rate stays constant over time. Of course, that's been changing a little bit as inflation's been going a little bit wild. So that's our rational model here. And, well, essentially, we could model every single choice a rational human being were to make with this simple expression. There's only 3 terms there. But, well, we don't because, well, people aren't rational. And I just want to mention the thing that I shrunk my face here. I forgot to mention, oh gosh, mention about is that this is a toy model. It's never actually used for analysis, but it does illustrate some important points. Where we do look at deviations from rational behavior, we change some of these factors in this equation. So we're not going to use this model to calculate anything in the course, so don't get too scared that we have to use calculus here. Ideally, students would have calculus when I teach this course, but typically the students I get don't have calculus, so I just don't teach with calculus involving the course, not at all. All right. Now, there's been a lot of famous gripes with rational behavior. Richard Thaler is perhaps the most famous. I got to shrink my face even more here. He's quoted as saying this Homo economicus, basically his example of a rational agent. I'm going to call them econs. That's also his nomenclature from his book. I think his second book is when he uses econs, misbehaving. Anyways, he says Homo economicus can think like Albert Einstein. They can store as much memory as IBM's Big Blue, which is a famous computer. This one was famous for chess. I think this one was famous for chess. And they have the willpower of Muhammad Gandhi. So they have all these brilliant traits. That's not really true of every human being. Those are very few exceptions. These people, Albert Einstein, Gandhi, and of course the computer. So the standard model, right, it's really, really good at first level approximations of human behavior. It's really good at making simple predictions, simple, clear, consistent, and you can derive it very easily with math. With logic is a really important point here. You can't derive behavioral economics with logic. You have to observe human behavior. That's what I'm going to mention in a second here. But to really advance our understanding, to really do some good in the world, we really need to understand real people and how they make choices. And if we miss that, if we neglect that people are imperfect, we're going to make a lot of really bad decisions as policymakers when we go and write laws, when we go and try and decide economic policy as the Fed, for instance. So we need to create models from real behavior, not from rational behavior. And the way we can do that is we can use the rational results, the rational behavior, and we can modify it to fit what we need to do. Modify it to fit real behavior that we observe. So there's a whole host of deviations from rational behavior. And I'm going to fit them into 3 major categories. And these 3 major categories, they come from Stefano Della Vigna. He's not in Boulder right now, I'm pretty sure. I could be getting that wrong, though. Anyways, maybe I shouldn't have guessed. There's 3 classes here. And again, this nomenclature comes from Stefano. So the first class here is non-standard preferences. That is that preferences might shift in different scenarios. So you could have different time preferences. Procrastination is an example in this. So I procrastinate in the near future. I put off work that I need to do in the near future. But at the same time, I'm planning for the far future. I'm planning for, what's my life going to look like 20 years from now? All the while I'm neglecting maybe going to the gym and exercising so that I have a better quality of life at 20 years from now. That's going to be time preferences. There's other behaviors in here that we're going to talk about. But that's one major example. There's referent dependent preferences. In this case, maybe the value of an object is dependent on market price. That's why if you go on Amazon, right, and you see all these discounts, you see all these slash prices. Oh, I'm saving 20% from market price and whatnot. People are going to think that value that they're getting a deal because they're buying it at less than market price. But there is no such thing as market price. That's a made up construct just so they can pretend that you're getting a deal, so they can pretend you're getting like 20% off on Amazon and sell you products. That's because people have this reference dependent preference. They anchor prices, they anchor their expectations to that market price, and they feel like they're getting a deal, so they're more likely to buy something. Next is risk preferences. Maybe they avoid small risks. They won't take a very small gamble, but they will take a very large risk. And primarily when these risks are very favorable, they have a positive expected payoff. They do this. So they avoid small risks, small gambles with positive expected payoffs, but they'll take large risks with positive expected payoffs, like investing in stocks, for instance. Then we have social preferences. My preferences do depend. I'm not selfish. I'm not acting in self-interest. My preferences do depend on society. I act altruistically, for instance. These are pretty self-explanatory. But we do have a pretty interesting section in here where we talk a lot of really interesting deviations from this and the observed impacts of those deviations. Then we have non-standard beliefs. So my beliefs in the probability of some states of the world occurring are influenced by irrational factors. They're not totally rational. I could be overconfident. I could believe that I'm more skilled than everyone else. So usually what we see when we do surveys in a classroom is that more than 50% of the classroom believe they're more skilled than most of their classmates. Usually it's about 80%. It's something pretty ridiculous that 80% believe they're in the top 50th percentile, which, okay, can't be true. And when you're overconfident, you make some poor choices. There's this thing that's really, really interesting called the law, and law in quotations, the law of small numbers. An example of this is that you assume that small samples are representative. So if I were to flip 2 coins, right, if the first flip comes up heads, if I believe really, really, really heavily in the law of small numbers, I believe that the next flip should come up tails. It should always represent the mean that, okay, 50% of the time it comes up heads, 50% of the time it comes up tails. Whereas in reality, okay, the chance of that next coin flip coming up tails is always going to be 50%, no matter how many flips I have. But if I believe in the law of small numbers, I inflate that to 100%, just so I get a representative sample there. Then we have projection bias, where maybe you believe erroneously in trends. The example I always use is from a book, a fictional book, but it's a fictional book that has a really interesting story here. It talks about a tribe that they welcomed bad luck because it means that good luck's going to come in the future because everything's going to average out, they believe. And then they dislike bad or good luck because it means that bad luck's going to come in the future. So they believe that, okay, luck always averages out over time, and you use up your luck if you have something good happen to you. You have good luck in the future, something bad happens to you. So they celebrate the bad luck and are afraid of the good luck. Then our third class of deviations from rational behavior here is non-standard decision making. This is that decisions may not be rational. They do due to either limited information, processing power. It's hard to think and make perfect decisions all the time. These are just a few of the examples that could lead to the non-standard decision making. So the first example here, this is limited cognition. Okay, I fail to see all available information. For instance, I could miss shipping costs if I were to go and buy a good on eBay or Amazon. So maybe I'm thinking I'm going to get a deal, but I'm paying $30 in shipping costs. That's limited cognition, limited attention. This should be limited attention. I actually call the topic limited attention in my notes, so apologies here. Some bad editing on my part. There's context effects that says that, okay, the more substitutes I have for good, if I go to a store, right, and I have, let's say, Cheerios on the shelf there. The question here is, am I going to buy Cheerios more often when there's the alternative there, Honey Nut Cheerios, or less often? How does that work? And also, if the store has their own brand of Cheerios, a knockoff brand of Cheerios to the left there, does that increase my willingness to buy Cheerios or not? Well, what classical economics says is as I have more very close alternatives to Cheerios in the store, okay, I buy less of that classic Cheerios because now I have these alternatives that maybe I go and move to. But what context effect says is that I add context in my purchase of Cheerios. I add more comparisons to that purchase. It actually increases the demand for that initial box of Cheerios, even though I'm adding alternatives I could buy. People are going to buy then the Cheerios and maybe the Honey Nut Cheerios, the alternative, because they compare the two. They say, oh, hey, I'm going to buy both of these. Therefore, I'm guaranteed to get a good product, something of those lines, that line of rationalization. We're going to talk about that, of course, when we get to that lecture. Then we have social pressures. People make decisions based solely based on what the crowd does. They maybe don't believe in their own rationalization. They just follow the crowd. And heuristics, which really all of these are heuristics or decision-making heuristics, but this is just any real shortcut or trick in decision making that could occur that's going to prevent me from making the best possible choice. So technically, all these are really to do with heuristics, but I like to bundle it in and play catch up at the very end of my lectures, so I put it down here. I think I clicked too quick here. All right. So now we come back to the slide here, right? Rational behavior is really, really important, and we really need to advance our understanding by studying real people, by studying these deviations from rational behavior. But it's very hard to do. It's not very straightforward. So there's several approaches. The first, this is where behavioral economics really originated. That's with Kahneman and Tversky. And he wrote all these sorts of papers. Kahneman and Tversky is really the one that started it. They're Nobel Prize winners. And this is with lab and classroom experiments. So what these do is they provide students with real incentives, money, extra credits, maybe just winning a game or winning some prize. And they do this to interact in some economic decision or scenario, to make a choice in some economic scenario. And I give a lot of these classroom experiments throughout my lectures, so I try not to provide an example here to spoil them. But they're just working with students and making them choose things and see if the students are rational. Then we have natural experiments. They look at maybe changing some factor in the real world or some factor that change in the real world and see how people make choices and how that choice changes as this factor changes. And then there's data-driven approaches. You could also include applied theory here. This is where you study large data sets. This is primarily in marketing they do this. Of course, I'm in this literature. And so they study large data sets and observe if behavior matches with rational behavior. Now, this last one's a little bit complex. I don't cover it in this course. I guess I covered the results of my paper, but I don't cover the experimentation here. We're just going to stick with these top two primarily in the course. I got to shrink my face again. Apologies there. Okay. Now, in order to have something verified as a deviation from rational behavior to study human choice, researchers, they need to not only prove that the results are empirically unbiased, that their results are true, they're not impacted by some outside factor that they're not controlling for. That is to say they have identification. And sometimes you would have covered identification and external validity in previous courses, but not always. So I mentioned it here. So you need to have this unbiasedness that my results are true. They give the true relationships between two variables. And we're going to cover what identification is in a few slides here. But they also have to apply and show that they apply to general settings. They affect everyone. External validity. I guess I usually split the lectures here, around here, and have one class. Okay, I talk about what I talked about in the first half, and then this stuff in the second half. But anyways, I'm going to go through it all right here in this video. So we need to show these two things. So identification, right, it shows that analyses are unaffected by factors beyond the factor of interest. In this case, in behavioral economics case, studying some cognitive bias, which are those deviations from rational behavior I presented a little bit ago. An example here, the effect of a recession on stock prices. It can induce projection bias, risk preferences, and other cognitive biases. But you can't separate these impacts from the impact of the recession itself on stock buyers' behavior because it's just going to naturally depress people and make them less willing to buy stocks. So maybe they're not avoiding buying stocks due to these other factors, projection bias, risk preferences, etc. External validity. That is that the observed effects, that what you do find, applies to all settings. So a question you could ask is, do classroom experiments apply to real behavior in actual markets? Are the incentives comparable? Are students representative of all decision makers in real markets? And the answer would be, of course, no, but often we have to rely on classroom experiments because we don't have other settings to examine these behavioral biases, these cognitive biases, these deviations from rational behavior. So it's unlikely that classroom experiments really apply to the real world. Students in a college classroom, they're going to be much smarter than your average human being, your average person in the marketplace. So already you have sort of a different sample there. You're not comparing apples to apples. But anyways, all the same, we tend to use lab experiments, the classroom experiments, and trust the results slightly. I don't really trust the results. I don't really present the results as factual much in my course. Sometimes I do in simple decisions, but not always. Mostly I stick to natural experiments. Anyways, you could also ask this question about an industry, something that studies a specific industry. For example, taxi cab drivers are very heavily studied in the reference dependence literature, in reference dependent preferences. And the question could be, do they apply do these represent all workers? And again, it's unlikely that they do, but still you can take something of their choices. You can get something and derive something from it. So it tends to be relevant. And when you write a paper, you have to defend all these relevancies. That's why I'm going on and on about this, because I just wrote a few papers. Anyways, I'm in that mindset. So I'm going to sum up behavioral economics approaches in their basically how hard it is to prove external validity. Is it hard? Is it easy? And how easy is it to defend identification of the results? So we're going to start with this bubble applied theory, which basically says I'm going to take theory and I'm going to directly apply it to real world settings or equilibria. You could look at income targeting or communication as examples of this. We're not going to work with it too much because, well, theory is very hard. It's very mathematical, this approach, and I try to limit the math in this class as much as possible. The second bubble, so in applied theory, it's very hard to demonstrate external validity, and it's incredibly hard to demonstrate identification. Now, the second bubble here, again, this one we're not going to cover too much in this course. That is data-driven methods. So using large data sets and big data techniques to extract some aspect of human behavior. So digital markets rely on this a lot. You can look at techniques like bunching or differences using a kernel approximation. They all fit here. But these are the ones we're going to focus on. First is lab experiments. Identification is really, really easy to get because you're the experimenter. You can directly change the factors so that the only thing that's changed in the experiment is what I've changed, is something that's meant to trigger this cognitive bias. I could have added more risk to the experiment, for instance. I could have added a change in presentation to invoke reference dependence there. Anything above. But yeah, these tend to be really, really easy to get identification where I design experiments for students. But the external validity is incredibly hard because, okay, it's students. It's not real people, and it's not real people making decisions with real money in which they might act differently. And the last bubble here, natural experiments. This is really the gold standard where you have some experiments in real markets. You either design it or you observe it. It's very easy to identify. It's also very easy to argue external validity because you're observing real behavior in a real market that tends to be relevant to the real world. So this is here. Now, what are the goals of behavioral economics? Jumping through here. Storm. My dog's just camped out right here, rushing me along. Anyways, apologies for that. So what are the goals of behavioral economics? Well, it's to describe real human behavior. And then also one of my major goals is to inform policy. That's something I like to do. I think something I think is fairly important. Excuse me. And then on top of that, it's to correct markets in a way. Sometimes it's used to exploit markets. That's why I have it in quotations there. So in markets, right, many people are already aware that others and themselves exhibit cognitive biases, and they learn to exploit them and dominate markets. They learn to do really, really well exploiting others' cognitive biases. So with behavioral economics, right, you can limit this imbalance in markets through proper mechanism design. You can design a market so that even if someone's cognitive biases, even if someone's non-rational, deviating from rational behavior, they're still able to get a fair chance in a market compared to someone that is rational. Um, Education of these cognitive biases, right? It should be educating individuals to overcome cognitive biases can help, although there's very limited impacts of education, as we've seen in experiments. And you can also redesign markets and marketplace interactions to improve the efficiency of exchanges to limit the role of cognitive biases in decision making. Oh gosh, apologies there. So these are the major goals here. One of the most relevant is to correct markets because markets are really riddled with exploitations of cognitive biases. I'm going to call that out as much as possible in the course. And of course, the course goals, right? It's to describe real human behavior and economics. Again, inform policy. I mean, as a part of teaching this course, I have students write policies using behavioral economics. This tends to be a really, really good application of behavioral economics. And students do really, really well with this stuff. I actually just had students inform real policy, right? A real policy that went into action in a few firms. They won some national competition in their policy for the course. So there's some pretty relevant stuff here. Anyways, in the course, you're going to create your own policy using behavioral economics, which is designed to improve the impact of whatever policy you do. So you use the behavioral economics, you use this presentation to invoke, to exploit for good cognitive biases of your audience. So you're going to use behavioral economics to improve the impact of the policy, the efficiency of the policy, and the uptake rate. To overcome other market failures such as externalities, monopolies, these things that we'll learn, and also to learn valuable presenting coercion skills in this course. So all this using the behavioral economics you'll learn here. Okay. So that's the course goals. That's primarily what you're going to learn in this course. Now, so we're going to circle back to identification and externality. So I'm going to go somewhat quickly through that because I'm not sure of the audience I'll get here. I'll go and take my time. As long as my dog gives me the time. So identification, right? The goal of most economics, of most studies, is to relate two variables. To say, okay, I want to understand what's the effect of this variable x here, what's called my independent variable often, on my y here, my dependent variable. And I want to know, okay, what is that effect? Well, that b here, that's going to be my effect of x on y. So if I increase x by 1, I'm going to increase y by whatever b is. You would have already seen this because elasticity is the change in log's price, the effect of the change in log price on the log of quantity demanded. So the x acts as the price. I change the price. I'm going to change the quantity demanded. I'm going to change it by elasticity. Now, this is theory. In theory, you have this relation between these two variables, but in the real world, you have a statistical association between the two variables that we need to observe. And this is where identification comes in. We have not only this effect of x on y, which is in truth, in theory, in ideal world, this big capital B, but what we observe in the reality is this little b because we have a finite sample size. We don't observe every last interaction possible to be certain that we're observing this relationship. We have an approximation here, this lowercase b. And that approximation is going to be subject to some additional error here, which u usually represents. Now, what we need for identification is only that b is a good estimation. This lowercase b is a good estimation of this uppercase b. And it will be when the relationship's identified. And to have identification, really all you need is that there's nothing in this u, there's nothing in the error term that I'm excluding in my regression, that I'm excluding in my statistical association, that affects both, and it does have to affect both the x and the y. If it just affects the y, it's no problem. If it just affects the x, it's no problem. But if it affects both, it's a big issue. It causes it to be unidentified. So as long as there's nothing in the u and the error term there that's missing that affects both x and y, we're good to go. We're identified. And really this sums up to essentially not having omitted variables. So I'm going to give you guys an example here. And that is maybe we want to estimate the effect of hair length on weight. Maybe we're interested in that. So there's some relationship here that we think theoretically is true, not just, okay, your hair is longer, so you wear fractionally more. It's that maybe your hair is longer, so it discourages you from exercising because sweaty, long hair is a whole mess. You don't want that. So we're interested in that relationship. So if we were just to relate, okay, hair length to weight, do we have omitted variables? Do we have something that's going to cause some bias, something that affects both weight and hair length that's missing when we relate just hair length and weight? So we have to think about what else affects weight, and then in that category of what else affects weight, is there anything related to hair length? I'm going to give you guys a moment to think about that. Just sit here and not talking awkwardly for a moment. I'm going to give you my answers here. So there's several different answers that could be in here, several things that are exploited. The first is gender, okay? If you're not controlling for gender, if you don't have gender in this relationship here, okay, girls tend to have longer hair, and they also tend to have lower weights. So you're affecting both variables. It's omitted. The region in which you live, okay, Europeans, they tend to be much skinnier than Americans, and they also tend to have longer hair. So there we go. That affects both hair length and weight. So this would very much be unidentified. It would not be identified because of these factors. And I have this because, okay, you can estimate the direction of the bias. We don't do anything with it in this course. Now, something you would have learned in your econometrics class, my face just barely blocks that change there, is ceteris paribus. And that stands for all else equals. So we compare two things, right, a y and an x. We want to say that only the x is changing. Only the independent variable here changes. But it's almost impossible to have this be the case, because in order to have this be the case, to compare two different things with only the x changing, you need to have a lot of control over the situation. Really, what you need is two exact clones in the exact same second with slightly different parameters. So you need like parallel universes, all sorts of things. It's impossible. So we are able to settle with getting it through some techniques. The first is going to be lab experiments. You usually do a randomized control trial. You take two large groups. You have one that's treated. You change something. You change the X variable. You give them some drug, and the other you don't change a thing. Although you do give them a placebo because you don't want the placebo effect to run havoc on your experiment. So lab experiments is very simple. We take two large groups. Those two large groups aren't exactly the same. They don't have perfect clones of one another, but they're two large groups of people, and there's, okay, once you get a group large enough, they're going to be statistically very similar in their behaviors. So we're pretty much good to go there. Natural experiments, right? We're going to try and do a randomized control trial, but we can't because, okay, it's the real world that we're experimenting with. So we're going to try and induce a randomized control trial. We're going to try the same thing, but in a real setting. We're going to look at two different groups. One has a different X and the other doesn't, or maybe not two large groups, but different people with different X's, and we look at the changes in the effect on Y of those people. So some examples of real randomized controlled trials in natural settings are distribution of mosquito nets in Africa, providing housing vouchers in everywhere in the world, and education vouchers, and seeing these effects on education and outcomes. All right, hold on here. It's okay, Vlad. Come on, it's okay. All right, I'm just gonna go slightly sideways so I can pet the dog while I finish lecturing. All right. Sorry, I didn't realize I had split natural experiments here. So you can have induced randomized control trials in real settings, or you can do what's called difference in differences. This is a pretty popular method. And that is that you change something in the real world, in the natural settings, and you change something particularly that affects one group but not the other. So if a firm were to close as a primary example, I give another example of viral video. If some YouTube channel has a viral video and another doesn't, you can observe what happens with the changes in those groups' behaviors. And these are the most common techniques to achieve what's called ceteris paribus, which really we don't get perfectly to ceteris paribus, but we get damn close. We get really, really close to it. So with this, we can achieve identification because the groups here, the only thing that we're changing, we're sure, is the x. There's nothing in the error term that we're omitting because we're choosing the groups, and we're choosing the groups to be similar to begin with, so they're directly comparable. Now, this is an amended discussion. There's a very good discussion of this by Josh Angrist on Margin of Revolution University. So I recommend checking into that if you're more interested in this topic. But this is about all we need to dive into here. And we're going to talk about the external validity, the identification of real experiments in the course itself. External validity here. That is that the group experimented on fits other settings. This one's much more self-explanatory than identification. Um, one thing to note here, okay, people obviously act differently in a lab or in a classroom than in the real world. So you might not have the same effect between variables in the classroom as you have in the real world. Natural experiments, they're much preferred to lab experiments because they're done in the real world. Oh my gosh, what did I say here? Now, to overcome this, this bullet point should be under here. It should be in blue, like light blue here. Anyways, to overcome this in the classroom setting, usually what you have to do is you have to motivate that I'm offering substantial rewards. I'm offering something that's really significant, maybe like 10, 20 bucks, something that people really want. So they act the same as they would in the real world where they get that money. Now, another question you need to ask for external validity are specific groups representative? Do taxi cab drivers look at the rest of the world? Do YouTubers look at the rest of the world? These are the questions. But for the most part, it's really just we have to motivate that our results, that our experiment applies to real people, to everyone, or at least a significant enough group that we should be concerned about the behavior. And I have an example here to look at this. I'm going to very quickly just roll out the example here, talk about what I do, and then call it quits for the lecture here. So the goal of this activity, right, the real goal is to talk about identification and external validity. But the goal for students here is to estimate the tax rate's effect on yearly tax revenue. And we're going to assign goals. We're going to assign some heterogeneity to students. We're going to assign people to be rich, average, and poor. And the goal of the students here is just earn as much money as possible. So you're acting to earn as much money as possible. And usually I encourage this with basically points. I make it some math test. I say, okay, if you make the right choice in the right setting, you get the full points. Otherwise, you don't. The students have 4 choices to do this. They can pay taxes at the given rates, and they go through several tax rates. They can pay some fee for avoiding taxes. Obviously, you should never choose this. And you can avoid taxes by buying an offshore bank account for 100K, or just not work. You can choose not to work. Working incurs some effort, so it's not always the best. You're not endowed with this money. To start, you have to earn it. It's not always the best to work. So I looked through several different tax rates. I use 10%, 7%, and 5% primarily. I think I go up to 50% at some points, so that the average doesn't work, but I forgot it. And then I change the experiment, so now everyone's poor, now everyone's average. This is from the cover of American Splitter, one of my very favorite comic book covers. Average. Hey man, average is dumb. Great quote. Anyways, the final one, everyone's rich. Of course, Chappelle's show. That's come in here, this quote. And then what you want to ask yourself is, what's the observed effect of tax rate on tax revenue? If you do this in a classroom, if you do this and try this out, you're going to see that sometimes it's positive. Sometimes an increase in tax rate is going to earn more money, as you would expect, as the rational case would be. But sometimes it's negative. And it's going to be negative because people evade taxes as the incentive to evade taxes increases. So we don't really have an answer to this question. But we do have some things violated here. So what's violated with this experiment? Why do we get inconsistent results? Why do we get some bias here? Where sometimes we're positive, sometimes we're negative. Okay, is it external validity or is it identification? And really, it's both. It's going to be identification because paying taxes is a choice that depends on your outside option. What you can do an alternative to paying taxes. And that outside option is tax evasion, which I directly put into those slides there. And then, of course, some groups, right, they have greater access to this option. That's going to decrease tax revenue, primarily when it's the rich that have more access to that outside option to evade taxes. But also, you have external validity violated because students, they're not making choices with real money, and they act differently than they might otherwise. This is an issue I always have when I try fun class experiments. It takes a while for students to get with it. Now, keep in mind, I'm doing all these experiments just after students are coming back from COVID, so they're still kind of getting their feet wet. Maybe it's a lot easier as we get further and further away from COVID, but we're yet to see. Anyways, that's the end of this first lecture. So those are all the slides I have. Apologies for the slight rushing. The dog's going a little bit crazy here, but she'll do fine. I'll look forward to the next lecture. We're going to cover time preferences then. Okay, bye now.